Welcome to the Collection, Declaration and Basics Part 2. Before we get started, let's recall the visuals for list, set, and map. In this session, we will discuss the following data types that can be used within collections. Let's start with collections of collections. Here we have a list that accepts a data type. And we know that data type could be anything, a primitive or perhaps a collection. We have already seen how we can use primitive data types, but this time let's replace the data type with a collection. For example, a set. To make things more interesting, we can assign another collection to the data type, perhaps a map, and the nesting can go on and on. However, as a developer, our job is to keep the code clean, simple, and readable. This means overuse of nesting could possibly lead to confusion. Let's look at a few examples. Here we have a list that accepts a set of string. We can then have multiple strings within the set and multiple sets within the list. Here's how we would write our code. Let's assume we need to keep track of student names from multiple batches. To do so, we first create a set of each batch with the student names. Then we create a list that accepts a set of string and we sequentially add those sets to the list. We could instead use a map if we want to store a key for each batch. Here's another nested example where we have a list that accepts a set of lists. Within the nested list, we can have one or multiple strings. Within the nested set, we can have multiple lists. And likewise, within the outer list, we can have multiple sets. For instance, we would want to store a list of our favorite and least favorite TV shows. We can add those to a set. But hold on. We have got a duplicate element within our lists and we are now assigning those to a set. And set doesn't allow duplicates. Does that mean our duplicate elements will merge into one? And the answer is nope. The reason is our set accepts a list, which means that our lists as a whole must be unique. In this scenario, even though there are duplicate elements across our lists, each list is unique in its complete sense. Coming back to the nesting, we finally use another list to store the set of lists. Coming to Apex-defined types for collection, we have already gone through some of the Apex-defined data types, which are nothing but built-in Apex classes provided by the programming language itself. Till now, we have briefly discussed only the classes that are related to data types. However, there are various other Apex classes such as schema, HTTP request, JSON generator, and many more that can be used to deal with other types of data in Apex. To get the full list of classes, check out the links in the description. Let's start with the schema class. Here we create a list of string that has SObject API names as the predefined values. We then pass the list to the describeSObjects method of the schema class, which will return the result of type describeSObjectResult. Finally, we loop through the results and debug the label and the total number of fields for each SObject. Next, we look at the HTTP request class. Let's say we want to send subsequent requests to the ChatGPT and the Spotify APIs. We first declare those requests individually and then use a map to store those HTTP requests with their associated names. Furthermore, we loop through each key within the map variable using the keySet method of the map class. Within the loop, we debug the name for which the callout is. Then we initiate the HTTP class followed by getting the HTTP request data from the map variable using its key. Finally, we send the request and debug its response. Last but not the least, let's look at the JSON generator class. As the name suggests, this class can be used to generate JSON data. For instance, here we have a JSON structured example of account information. We can accomplish this in Apex by creating a JSON generator object using the createGenerator method. We can also pass a Boolean parameter if we want a beautifully structured JSON output. We then start with the object, then all the attributes such as account name, is premium, and the total contacts. And finally, end the object. Next, we have another JSON data that holds the phone information for the account. We again define the structure for this and add both the JSON data to a list collection. Before we move to the final topic, here's an important information to consider. In Apex, there is something called a namespace, which is a way of organizing classes, interfaces, and other components to avoid naming conflicts with other code. Some examples include system, metadata, database, and so on. All these namespaces are further subcategorized into a specific type of information within the platform, and they all have the built-in Apex classes designed for their purpose. Up until now, we have only dealt with types of information that are part of the system namespace. To know more, check out the links in the description. Final topic of the video, user-defined types, refers to the classes that are created by us. For example, we have an animal class with few global variables, a constructor, and a method. We can then use either of the collections, a list, a set, or even a map to fit our purpose. Before we end this session, I would like you to practice on what you learned using the following scenarios. Your job is to determine what Apex class from the system namespace can be used for each scenario. Remember, we can define what class to be used based on the type of information we are dealing with. This has been Collection, Declaration and Basics Part 2. If you found this video helpful, please do like and subscribe. Don't forget to comment your practice answers in the comment section down below, and I will see you in the next one. Until then, be safe and take care. Peace.